Let's take a look at example 3 with triangle proofs. Draw the figure in your notes, write the given and the proof statement like I did. We have that LMNO is a parallelogram. So that's a symbol for a parallelogram, and sometimes that's all they will write, and they will assume that you know that that's a symbol for a parallelogram. So therefore, all the qualities we know about a parallelogram would be true for this figure. So that statement actually means a lot. And then we're asked to prove that angle M is congruent to angle O. So we're going to label our figure with things we know about a parallelogram and see if it can lead us to how we could prove that angle M is congruent to angle O. So let's get started. So a parallelogram, as we know, has both pairs of opposite sides are parallel. So that tells us a lot of information. So I'm going to go ahead and draw in the parallel line symbols. So then we know that this line LN, this segment, the diagonal right there, would be like a transversal for the parallel lines. So that tells us more information. So let me use a different color here. So if we know that LO is parallel to NM and it's cut by this transversal, we know those two angles would be congruent. And then we can also say that the angles on the other side, for the same reason, would be congruent. Those are alternate interior angle pairs, because that would be like our transversal. Sometimes it helps if you continue that line so you can kind of see these lines are parallel, cut by a transversal, so those are alternate interior. And the same way these lines are parallel, and they are cut by that same transversal, so now we can easily see that these would be congruent because they would be alternate interior. So if you need to draw the lines out to make it look a little more like those figures we saw with parallel lines, that is perfectly fine. It is very okay to draw on your figure. Just draw with a pencil so you can erase it if you need to. But we still haven't quite gotten to our proof statement yet, but we do know a lot about the figure now. We have two pairs of angles. We also can tell that these two triangles share the side LN by the reflexive property. And so now we have enough information to conclude that triangle LON would be congruent to triangle LMN because of angle side angle. So we have enough to prove those triangles are congruent. And then that leads us to the fact that these would be congruent angles, because once you've said that triangles are congruent to one another, you know all of their sides that correspond and their angles that correspond would all be congruent to one another. So that would be enough for us to go ahead and state that. So let's go ahead and get to writing all of this down in our formal two-column proof. So number 1 is our big given statement. We were given LMNO, and we can draw a little parallelogram symbol, is a parallelogram. And that was given. That's a lot of information. It looks like a small statement, but it gives us a lot of information. So then we can state that, we can say that LM is parallel to ON, and let's see, LO is parallel to MN because opposite sides of a parallelogram are parallel. And then we know from those two sides, two pairs of sides being parallel, that those angles we just named would be congruent because they are alternate interior angle pairs. So we're going to say angle MLN would be congruent. MLN is congruent to ONL, so angle ONL, and we don't have to write the word and. It's assumed that it's both of these if we just list them there. So let's just take that out. So that was MLN. Now we need OLN. So angle OLN is congruent to angle MNL. You gotta take your time and make sure you're labeling it right. And those are true because those are alternate interior angles, and those are congruent. So then we need to state that LN is equal to itself. So LN is congruent to LN because of the reflexive property. And that gives us enough information to say that these two triangles are congruent. I'm going to try to squeeze all this in here. So triangle LON, triangle LON is congruent to triangle LMN because of angle side angle. We can tell it goes in that order. And then last but not least, we can state that angle O, or angle M, we'll say it the way they did, is congruent to angle O because of what we call CPCTC. This stands for corresponding parts of congruent triangles are congruent. So once you have proved triangles are congruent by one of those 5 methods, you can then conclude that any of their corresponding sides or angles are congruent. So it's a good method to use, like after you've proven triangles, you can then state sides are congruent, angles are congruent, whatever it is that you need to say are congruent to one another. So let's look at the other 2 ways we could write this proof. Actually, I take that back because I've just put the flow proof here. I really feel like you could write out the paragraph proof if needed, but I wanted to focus on the 2-column proof and on the flow proof for this one since they do take several steps. So for the flow proof, I put that LMNO as a parallelogram was at the top of the list, of course. That's given. That tells me that OL was parallel to MN and LM was parallel to ON because both pairs of opposite sides of a parallelogram are parallel. So that's a good reason to state that. From these 2 sides being parallel, I was able to conclude that these 2 angles were congruent because they're alternate interior. The same here, or over here I put it. So from these 2 sides being parallel, I was able to conclude these 2 angles are congruent because they were alternate interior. In the middle here, I put the reflexive property because that one side was congruent to itself. So we have angle, side, angle, like I like to put with a flow proof as much as I can, put it in order. Then we state that triangles are congruent by angle, side, angle. And then we state that parts of them are congruent. So those 2 angles were congruent because of what we call CPCTC. So I put that over here for you to add to your notes. When you see that statement, if you're not already familiar with it, it means corresponding, that's the C, parts, that's the P, of congruent, that's the other C, triangles, that's the T, are congruent, and that's the last C. So it would make sense that we just write this, because in math we like to write shortcuts when we can. So instead of writing all of those words every time we need it, we just use this phrase to mean all of that. So add that to your notes so you have it. And in case you need it, it'll be there. And these are the proofs that go with example 3. And you could write the paragraph proof. I feel confident that you'd be able to write that out as well.